This is a mixed concept MCQ which requires us to know a bit of oscillations and of course dimensions. This is from NEST 2011, question number 6. A spherical dewdrop, when deformed slightly, oscillates about its equilibrium shape. The physically relevant variables to describe the frequency of this oscillation F are its mass m, radius r, and a third variable q, where q could either be the universal gravitational constant capital G or the surface tension S. One must decide the relevant variable q and employ the dimensional analysis to express F as k into m to the power x r to the power y q to the power z, where k is a dimensionless constant. Then a x negative 1 upon 2 y 0 z 1 upon 2, b x1 upon 2 y negative 3 by 2 z1 upon 2, c x1 upon 2 y 0 z negative 1 upon 2, and d x negative 1 upon 2 y negative 3 by 2 and z 1 upon 2. Acha. Now I called it a mixed concept MCQ. Okay, I called it a mixed concept MCQ because there are two stages here. Most of us will be able to get the second stage very easily, and that is employing the dimensional analysis. Okay, but how to decide whether it is a surface tension S or the universal gravitational constant G on which the frequency depends? Okay, we still don't know that, and that is why I've called it mixed concept, right? That is something that's very critical for us, crucial for us. Like, how are we going to determine whether it is the capital G or surface tension S? Okay. And in the exams like IISc aptitude test or the NEST, you can expect such MCQs because of two reasons. First, the number of questions is small. Okay, especially in IIT we have only 15 questions, and they want to cover a lot of syllabus, 11th and 12th. So this is how they can combine the concepts and prepare a problem. And other thing is, you will get to know this only if you know oscillations, how oscillations work, how surface tension works, and how dimensions work. If you know these things independently but are unable to connect the things, bring out the relevant things, then you will find these MCQs to be slightly difficult, but they're not. There is no integration, there is no differentiation, there is no vectors, there is no trigonometry. Basics, okay, only basics. Okay? So that was NEST 27, question number 6. There is a separate playlist that I have prepared for NEST PYQs for physics and mathematics, and also IISc aptitude tests. The links to those playlists are found in the video description. Please subscribe to our channel and help us grow. Now, I'll first tell you the answer that you might think would be the trick. Okay? So you'll say, let the frequency's dimensions be written, so we know that the t raised to negative 1. K is anyways a dimensionless constant. So let us say m raised to x, radius is length, so L raised to y, and then we have got q raised to z. Okay, now there are two options here. Either we can go for a gravitational constant G, or we can go for the surface tension S. Correct? Now this is a multiple choice question, so only one option is right. And if you put G as q and S as q and work out the dimensional analysis and get the values of x, y, z, then options D and A turn out to be the right options. So we have to first decide whether it is the surface tension that is going to play a role or the gravitational constant that is going to play a role. Okay, so here is how to decide whether it is G or S. Okay, look, they're saying it is oscillating about its equilibrium shape. Okay, oscillating about its equilibrium shape. Now, by default, oscillations refer to restoring force. Correct? By default, oscillations refer to restoring force. Okay. Now, what restoring force could it be? Will it be the gravitational force or could it be surface tension? So here is what we can think about. Okay, let's say this is the ground on which our spherical drop rests. Okay, let us show it in blue color. Okay, let's say something like this. Okay, this is the drop in the original position. Now clearly this is not spreading. Okay, this is not spreading, but it is trying to maintain the least possible area of contact here. Can take us to the solution. We can say that it's the surface tension. Okay, it's the surface tension that keeps the surface area minimum. Okay, keeping the contact minimum. Okay, now suppose what we do is we slightly deform it. Okay, we slightly deform it. Okay, let's say we apply a deforming force. This is as good as pulling the mass, okay, which is hanging on the spring and then releasing it. Okay. Now think about it. What will happen due to this deforming force? We are going to assume that it is not going to destroy the drop. It is not going to destroy the drop. So obviously it will now be an egg-like shape. Okay, it will take shape of an egg. Okay, something like this. Okay, now what has happened because of that? Because of that, the surface contact has increased. Okay, surface contact has increased. Now you come to the point. Because surface contact has increased, surface tension will try to decrease it. Correct? Because the surface contact has increased, surface tension S tries to decrease it. And it now takes the drop, okay, it basically rushes the drop towards its equilibrium position. But by the time it reaches the equilibrium position, it has acquired some speed. And because of that, it will go to the other extreme. Okay, and what would that other extreme be? That other extreme would be a shape like this. Okay, the other extreme would be a shape like this. And then it will keep on oscillating. Okay, so which is the physically relevant variable here? The physically relevant variable here is surface tension S and not the gravitational constant G. Got it? We started with the deforming force or the restoring force, because to restore we first need to deform it, right? We need to perturb the system. Okay, so if we do that, its contact will increase. Surface tension comes in action. It will try to reduce the area of contact. But by the time it reduces and attains its original shape, it is in equilibrium. It has now acquired what? It has now acquired velocity. Okay, velocity. So it will again deform. So that oscillation will continue. So it's surface tension that is going to play an important role. Got it? It's surface tension that is going to play an important role. And we might also argue like this. Okay, throughout our system, because the drop oscillates about its mean position. Okay, well, so the center of mass of the bulb of the drop remains constant. Now allow me to shift it a bit here. That drop should have been drawn a bit downwards. Okay, let's do it. Okay, let's do it. Take it a bit downwards there, and now we can erase this line and draw it there. So the center of mass doesn't change. The location of the center of mass doesn't change. Got it? So what's the conclusion to the first part? It's surface tension that is going to decide. So the relevant variable is S, and now we can continue with this equation and decide whether it is surface tension or G. Okay, we have already decided that. Now it's no longer G anymore, it's actually S. Okay, now let's try to write down the dimensions of the right side. We know that surface tension's dimensions are m t raised to minus 2. Okay, m t raised to minus 2. So mx Ly m raised to z t raised to minus 2z must be equated to t raised to minus 1. So that gives us z as 1 upon 2. Okay, z as 1 upon 2. X plus z should be 0 because there is no m on the right side, so x should be positive 1 upon 2. And what about y is 0? Okay, oh sorry, x should be negative 1 upon 2, my bad, x should be negative 1 upon 2. So negative 1 upon 2, 0, 1 upon 2. Negative 1 upon 2, 0, 1 upon 2, that is option A. Okay, that is option A, so A is right. And well, at the beginning I said D is also there, so I have done that for you. Here is the analysis. What I did is I have first found out the dimensions of G based on its units, and then I have substituted those here. Okay, for well, so initially we substituted S there, now we have gone for G, and it also gives us an order triple x equal to negative 1 upon 2, z equal to 1 upon 2, and y equal to negative 3 upon 2, which matches with option D. But we know option D is not right. So any equation which is dimensionally correct may or may not be of any physical relevance to us. Okay, so it's not just a blind exercise of putting the dimensions and reaching the conclusion. Okay, thank you.